Okay, so let's consider a different function. So let's say we have the function f of x is equal to 2x squared minus 3. Right, so we are given this function, and now we want to find the value of the output when x is equal to 2. So we want to find what this is equal to, right? So when x is equal to 2, what is the value of our function? So we can easily find out the value of our function for a certain value of x. All we do is substitute this value of x into our function. So we have f of 2 is equal to 2 times 2 squared minus 3. Right, so we have 2 times 4 minus 3 is equal to 8 minus 3, which is 5. Right, so this is the value of our function when x is equal to 2. Now, what if we are asked to find all the values of x such that f of x is equal to 47? So in this case, our output is given. Now we want to find the corresponding inputs that give us this output 47. So once again, we know what our function is. We have f of x, which is equal to 2x squared minus 3. Now we just equate it to our output, which is 47. Right, so now we can just try and solve this equation for x. So if we solve this equation for x, we have 2x squared is equal to 47 plus 3. Right, all we did was add 3 on both sides, and this is 50. Now we can divide both sides by 2, which will give us 25. Right, so now we can just take the square root of both sides, which will give us x is equal to plus or minus square root of 25, and now this is plus or minus 5. So now we have two values of x. So we can have x is equal to 5 or x is equal to minus 5. Now, once again, our function that was given to us was 2x squared minus 3. Right, so this is our values of x, and we can easily check our answers by substituting each one of these values into the function to see if we get our output 47. So when x is equal to 5, we have f of 5 is equal to 2 times 5 squared minus 3. So we have 25 times 2, which is 50, minus 3, which is 47. And similarly, if we do the same thing for f of minus 5, then we see that we get the exact same answer, right? So our values of x are correct. Now, considering the same exact function once again, so we had f of x is equal to 2x squared minus 3. Right, so we're considering this function again. Now, this time we want to find f of 3x plus 1. Right, so we want to find our output of this function when our input is this expression. Right, so in this case, all we do is just we substitute 3x plus 1 into this function for x. So we have 2 times 3x plus 1 whole squared minus 3. Right, so now we just expand this and multiply it with 2 to get some expression. So in case you're unfamiliar with how to expand something like this, we have 3x plus 1 times 3x plus 1. So we just multiply the first term with the first term of the other expression, and then the first term of this expression with the second term, and then the second term with the first term, second term with the second term. So doing this, we have 3x times 3x plus 3x times 1 plus 1 times 3x plus 1 times 1. Right, that is it. So we have, this is 9x squared plus 3x plus 3x plus 1, which is just 9x squared plus 6x plus 1. So we have 2 times 9x squared plus 6x plus 1 minus 3. And now we multiply 2 with each of these terms. So we have 18x squared plus 12x plus 2 minus 3. And then this gives us minus 1. Right, so when our input is 3x plus 1, our function gives us this corresponding expression to the right. Right, so now let's look at a different function. Let's say we have g of a, b, comma, c. And this is equal to 3a minus 2b plus 7c squared. Right, so we're given this function. Now in this case, you can see that we have 3 separate inputs. Right, so we have 3 variables in our function. So the question is that we have to evaluate g of 3, minus 5, and minus 1. Right, so how do we do this? Well, in this case, we know that a is equal to 3, b is equal to minus 5, and c is equal to minus 1. Right, our inputs are given. All we have to do is substitute these values into the function g. So doing so, we have g of 3 minus 5 minus 1, and this gives us 3 times a, which is 3, minus 2 times b, which is minus 5, plus 7 times c squared, which is minus 1 squared. So we have 9. We have a negative sign and a negative sign, so we get a positive, plus 10 plus we have minus 1 squared. Right, so any number that is taken to the power of some even number will give us something non-negative. So in this case, we have 7. And this is equal to 19 plus 7, which is 26. Right, so our output, when our input are these, is equal to 26. Right, so now let's say we have defined g of b, comma 2 minus 1, and this is equal to 21. So in this case, our input is b, 2 minus 1, but b is unknown. Right, our output is given. Our output is 21. We just have to find the value of b. Right, so how do we do this? Now we know that these inputs or these variables, they're just dummy variables, right? So these are just dummy variables, meaning you can easily just replace these letters or these symbols with some other symbol and we will still have an equivalent equation. So now in this case, they're referring to the first input as b, whereas in the original function, the second input is referred to as b. So to avoid any confusion, we can easily write this as d, comma e, comma f. This will become 3d minus 2e plus 7f squared. Right, so now in this case, d is equal to b, e is equal to 2, and f is equal to minus 1. And now we can just substitute these values into our function g. So now we have these are wrong. So now we have for g of b, comma 2, comma minus 1, we have 3 times d, which is b, minus 2 times e, which is 2, plus 7 times f squared, and f is minus 1. So now we have 3b minus 4 plus 7, and this is equal to 3b plus 3. Right, and we have our output that is given to us, and that is equal to 21. So we equate this expression with 21. Right, so now we can solve this. So we have we have 3b plus 3 is equal to 21. Subtract 3 from the left side and the right side, and we have 3b is equal to 18. Divide both sides by 3. Define b, and this is equal to, sorry, this should be 6. So b is equal to 6. Right, so this is our value of b. And we can easily substitute this value of b into our original function to see if we have, so if we take 6, 2, minus 1, input these values into our function, and you can check if this gives us 21. And if this is equal to 21, then our value of b, which is 6, is correct. Right, so now let's look at a different function. Suppose we have t of x is equal to ax to the power of 4 plus bx squared plus x plus 5. Right, so now we have to find t of 4 if t of, oops, this should be, so if t of minus 4 is equal to 3. Right, so now we have this vital piece of information given to us. So when x is equal to minus 4, our output is equal to 3. Right, so in order to find this, let's just find the expression that our function will give us when x is equal to 4. So we have x is equal to 4, and we have a times 4 to the power of 4 plus b times 4 squared plus 4 plus 5. Right? So now 4 to the power of 4 is 256. So we have 256a plus 4 squared times b, which is 16b, 4 plus 5, which is 9. Right? So when x is equal to 4, t of 4 is equal to this expression on the right. Now let's find t of minus 4. So t of minus 4 is equal to a times minus 4 to the power of 4 plus b times minus 4 squared plus minus 4 plus 5. So once again, we're taking some negative number to the power of an even number, right? So since it's an even number, we will get something positive. So we still have 256a plus 16b minus 4 plus 5. So we have 1. 16b plus 1. Right. So now how do we find the value of this output, right? That is what we have to find. Well, if we can find the value of this expression, 256a plus 16b, then if we have the value of this, all we have to do is then add 9 to that value, and then we will have t of 4, right? So we know that t of minus 4 is equal to 3, right? So let's equate this to 3, right? So this is the expression for t of minus 4, and this should be equal to 3. Right, so now let's solve this equation for this expression, 256a plus 16b, right? So we had 256a plus 16b plus 1 is equal to 3. We can subtract 1 from both sides to give us 256a plus 16b is equal to 3 minus 1, so we have 2. So now we see that 256a plus 16b is equal to 2. So we can just substitute this into t of 4. Right, so we have t of 4 is equal to 256a plus 16b, which is equal to 2 plus 9, and that gives us 11. Right, so we have found out the value of our output when x is equal to 4. So t of 4 is equal to 11.